Hey guys, it's Miss Delcambre. Today's Monday the 25th of January, and here's a rundown of our day. And just going to give you a forewarning, I'm sorry that there may be announcements coming on during this video. All right, so we finished up 11.3 today. You'll have your Builder 17 and your worksheet on 11.3. Tuesday, we're starting off writing equations to represent situations. Wednesday and Thursday, we're going to be doing adding and subtracting equations. And then Friday, we're going to be doing multiplying and dividing equations, and we have a Google slide activity that we will be doing there. So if you look in your Google Classroom, I've uploaded this material, and it's actually I've uploaded material and a video that we watched in class, so make sure you watch that. If you didn't get it, it's a combining like terms practice. We did this in class, and there's about 6, 7, 8 questions that we're going to be going over right now for our notes. So let's get going. All right, so we're going to be combining or combine like terms. This is our practice here. All right, so we did this on Thursday. We practiced it. You did it on Friday when you were practicing on IXL, and today is our third day of practicing it. Okay, so we have 6b plus 7b minus 10b. So if I'm looking for my like terms, I have 3 terms, 1, 2, 3, and I have a 6b, so I'm going to circle that. And then I have a 7b, and they're like because they both have the same variable at the end. Okay, so I'm both circling them, and this minus 10, there's nothing to go along with it, so I'm just going to leave it this as is. So when I combine, I'm looking at the coefficients. So 6 plus 7, that gives me 13b. My variable stays there. And then I'm going to bring down this minus 10. So when I combine the terms, I get an answer of 13b minus 10. Okay, let's look looking at number 2 here. I have 2x plus 3x plus 4y. Well, I'm going to circle this 2x first. Okay, I'm looking for anything with just an x behind it, and this 3x does, and I'm going to circle this plus sign in front of it. I'm looking, okay, 4y does not get circled, or it's by itself. There's no y, another variable y to combine with, so I'm going to combine these two. I'll look at the coefficient, 2 and 3, and I add those together. So I'm left with 5x. And then I just bring down this plus 4y. Think of it like order of operations. You didn't do anything with it, so you just bring it on down. Okay, number 3, we have 7x squared minus 2x plus 16. Okay, again.
This is the final call for second bus round. Final call for second bus round.
Again, I'm going to circle this 7x squared. Okay, I'm looking for anything else. Well, here's another x squared, so I'm going to circle that, and I'm making sure I circle the minus sign right in front of that x squared. Okay, and then plus 16. There's nothing that I can combine here with the plus 16 because it's my third term. So when I combine them, I have 7x squared minus x squared. So that gives me a 6x squared. Because there's an imaginary or an invisible 1 as a coefficient. Because it's only 1x squared. So 7 minus 1 gives me 6x squared. And then I just bring down this plus 16. Okay, let's look at number 4. All right, so I have a whole lot of z's here, but let's see, z squared. Do I have anything that goes with a z squared? Nope. There's no other number or variable that has a squared. Z. Okay, I have a z here. I have a z cubed. That won't match, but this one would. Plus 4z. Okay, because this is just a z. And then z cubed. There's no other cubed one there. So I'm going to combine my like terms. I can do this many different ways. I'm still going to get the same answer. So if I combine my like terms first, I have a z and plus a 4z, so I'm left with 5z. Okay, and then plus z squared, I did that one, plus a 4z cubed. Okay, and you know I'm the weird person that I always like to have my exponents going from greatest to least, so I would rewrite it as 4z cubed plus z squared plus 5z. No matter what, these both are exactly the same. They exactly are the same value. Okay? Let's look at our next one here. So we have 3y squared plus 3, open parentheses, times 4y squared minus 2, close parentheses. So we need to use a distributive property. Okay? And so I'm going to distribute this 3 to everything in my parentheses. So I'm left with 3y squared plus 12y squared minus 6. Okay, I want to talk to you about this. So if I looked at this out, let me just get this sticking out, and I wrote it out, it would look like this. Another way to show the distributive property: 3y squared plus one group plus another group plus another group. Okay? Do you see I have 1, 2, 3 groups of it? And if I totaled it up, 4, 4, and 4 gives me 12y squared minus 2, 2, and 2, 6. And those two are exactly the same. And then I just put my 3y there. 3y squared. Okay, if I'm looking at combining my terms, I have a 3y squared here, and then plus a 12y squared. And I have that minus 6. So that minus 6 doesn't have anything to do, combine with, so I'm going to leave it as is. So I'm going to look here. So look at the coefficients. Well, 3 plus 12 gives me 15. So I'm left with a 15y squared minus 6. So this is the combined terms of this expression. They're both equivalent expressions. This one is just with all my terms combined together. Kind of like a simplified version. It's like simplifying fractions, but simplifying an expression. Okay, so for number 6, same thing. I'm going to need to distribute this 3 throughout. So then I'm left with y plus 4 plus 3 times y gives me 3y plus 3 times 2 gives me 6. So when I'm looking here, I have a y, and then I have a plus 3y. So those two would be like terms. Then I have a 4 and a 6, but there's no term behind or variable behind it. So these two terms are alike. So when I combine, I like to combine my variables first. So 3y and y gives me 4y plus 4 plus 6 gives me 10. So once I combined my expressions here, combine my terms, I get 4y plus 10. Okay? All right, now we have a couple of questions here dealing with geometry. We're dealing with some triangles and rectangles here. So the following is an equilateral triangle with a side measuring 2y minus 5. What would the perimeter be? The perimeter of the triangle be? Okay, so key thing is it's equilateral. And I know an equilateral all has the same sides. They're the same. So this is 2y minus 5. This is 2y minus 5. And this is 2y minus 5. Okay, without writing it out and writing all of them out, I can use my diagram I have here to help me. So I can circle, well, this is a 2y, This is a 2y, and this is a 2y. Okay? Then I have a minus 5. Those are minus 5, minus 5, minus 5. Those are all like terms. So when I combine my like terms, I have a 2, another 2, and another 2, which gives me 6y minus 5, 10, 15. So I have 6y minus 15. Okay? You could have also did it another way. I'm just going to show you. You know, you had 2y minus 5. An equilateral triangle has 3 sides, so you multiply it all by 3. Do the distributive method. Okay, that would be 6y minus 15 for the same expression. Okay. Last one we're going to do. The following rectangle has a length of 2a plus 6 and the height of a plus 2. What is the perimeter? What is the perimeter? All right. So perimeter means I need to add the sides. Add the sides. Okay. So if I know this is 2a plus 4, across from it is also 2a plus 4. I'm sorry, 2a plus 6, then across from it's 2a plus 6. Okay? Now this side's a plus 2. This side is a plus 2. All right, now if I'm looking for my common terms, I like terms. I have 2a here and another 2a there. And I have an a here, which I'm going to combine, and an a here. Because it both there, that would be like 1a and 1a. Okay? And then I have these single digit numbers back here. Plus 6 and plus 6. Plus 2 and plus 2. So when I combine them, 2, 3, 4, 5, 6, I'm left with 6a. 6 and 6 is 12. 12 and 2 is 14. 14 and 2 is 16. So I use my diagram that I have to find my expression by combining like terms. You could have also done it another way. You know, the perimeter formula is 2 times my length, which was 2a plus 6, plus 2 times my height, which is a plus 2. Okay, I did the distributive method. I'm going to distribute throughout. All right, that would give me 4a plus 12 plus 2a plus 4. Okay, I have 4a and 2a, and I have a 12, and I have a 4. I'm going to combine them together. Again, I get 6a plus 16. The expression stays the same. Here, I use my model to help me find my like terms to combine them that way. Here, I've written out, using my formula of 2 times my length plus 2 times my height to find the perimeter. Okay, so that does it for me today. Your homework is 11.3. If you're in my class, you are not doing 1 through 4. I have eliminated 1 through 4 for all my classes. If you were in my class, you're watching the video, you will then know that 1 through 4 is not due. All right, so have a great day, and we'll talk to you later. Bye.